For 10 and 12, the directions tell us to answer two questions. A, is the relation shown in the graph a function? And B, does the relation have an inverse that is a function? So let's take care of A first. So A, is this a function? Well, remember, to determine whether something is a function, it simply needs to pass the vertical line test, which, oh, that's a terrible vertical line. Let's try it again. I'm going to approximate here, but clearly any vertical line I draw in this picture is going to touch the graph only once. So it passes the VLT, so you can write passes VLT, and use your implies arrow there, implies that this is a function. All right, but then for part B, which asks whether the inverse of this relation would be a function, then we have to, this graph must pass the horizontal line test, which one fail means it failed, so there it is. We've just demonstrated that this one fails the horizontal line test. So we write the fact that it fails the horizontal line test implies that the inverse is not a function. Then we go to number 12, same set of questions. So first question, is it a function? We use the vertical line test to make that determination. One vertical line touching it twice means that it fails that test. So we would say fails VLT implies that it is not a function. And then we go to B, which says, would the inverse of this function be, or this relation be a function? And that's the horizontal line test, and then this one passes the horizontal line test anywhere you want to put a horizontal line. So since it passes the horizontal line test, we conclude that the inverse is a function. Then on number 26, which I jumped down and picked this one up for this video because it's a related question, the directions here tell us to determine whether the function is one-to-one. And then if it is one-to-one, sketch the graph of the inverse. So we're going to review what one-to-one means. One-to-one means that for something to be one-to-one, it has to pass both the VLT and the HLT. So right out of the gate, when we do the horizontal line test, we see this one's going to fail. Now it does pass the vertical line test. I can put these in here all day long. So it is a function, but it's not one-to-one. So this is a function, but not one-to-one. Now the directions said that if it is one-to-one, that you should draw the inverse. But we're going to go ahead and play with this graph just so you can see how you would draw it if it was one-to-one. So to do that, let me bring in that picture one more time and play with it for a sec. Alright, so here's what I'm going to do. I'm going to go in and erase by coloring in gray, and this isn't perfect erasure, but it gives you the idea. I'm going to cut off half of this graph by kind of saying, let's just forget that was there. If this was the picture you were given, well then this one would clearly pass the horizontal line test, and it would pass the vertical line test, which would make it one-to-one. So by restricting the domain to, let me switch colors here so I can actually write. I'm gonna limit my domain for our consideration. So just kind of, this is not really number 26 because I'm changing it, but my domain here, let's say it was from 0 to infinity. So that would be just including this side of the graph. Then now that it's passed both the vertical line test in this form, then if I can restrict the domain to those values, then it would be, in fact, let me erase all this because I'm going to have to put my graph over there. So if I restrict my domain to 0 to infinity, then I would pass both. In fact, let me not say pass both. Let's say, because it does pass both the vertical and horizontal line tests when I restrict my domain, that does make it one-to-one. Therefore, I'm going to draw the picture now to show what the inverse would look like. Well, remember, the inverse of something is just the same coordinates but switched. So like if I have the point here, which is 0, 2, that means that the point 2, 0 is on the graph of the inverse. So the inverse of that point, or the corresponding point on the inverse, would be at 2, 0. And then the point 1, 1.5 would be about right there. So then I would go 1.5, 1 would put me right here. So I've got 2 points so far. And then I'm going to take the point 3, -2 maybe. So I'm going to go to the left 2 and up 3, which would put me like right here. And then I'm going to draw that curve out. So there's my reflection across of the given function with the restriction included. And remember, that has to go through and reflect across the line y equals x, which would be about right there. So that kind of gives you a better handle on how to do that. So that's how you would sketch it, is you just mirror the points by switching the x and y. And that's the end of this video.